first video, we have discussed about the introduction of dielectric materials. Now, in this video, we are going to discuss about the types of polarization. So, already we know about the polarization. It's nothing but when a dielectric materials is kept in external electric field, the dipoles are formed and hence dipole moment is arrived. That is called polarization. Now, the types of polarization, we are going to see 4 different types of polarization. First one is electronic polarization and ionic polarization and orientation polarization and space charge polarization. So these are the 4 types of polarization which I want to show in this PPT. So next we are going to move the first type of polarization, that is electronic polarization. So what is electronic polarization? So you just look at this definition, that is the displacement of positive and negative charges, which means that already I told you dipole is nothing but when a positive charge and negative charge is kept at a particular distance is called a dipole, I told you. So these dipoles, the displacement of positive and negative charges, which forms the electronic polarization, displacement of positive and hence dipole moment and material gets polarized. So for that I am going to show one picture. This is the picture. So here in the absence of the electric field, all the negative charges are surrounded by the positive charge, and in the presence of the electric field, the positive charges and negative charges are separated. Okay, so which means that there is a displacement of positive and negative charges. Because of that displacement, dipole moment is produced and the material gets polarized. So this is called electronic polarization. So the electronic polarization, which we can explain in terms of formula also, this is called alpha E. So alpha E, which is equal to epsilon naught epsilon r minus 1 divided by n. Here we know that epsilon naught is the permittivity of free space, epsilon r is a relative permittivity, and n is nothing but number of atoms per unit volume. Okay, so that's all about electronic polarization. So once again I repeat, electronic polarization is nothing but displacement of positive and negative charges, and which leads to the dipole moment and the material gets polarized. So next, second type of polarization is ionic polarization. Now you come to the ionic polarization. This is nothing but the same thing, but here what is happening compared to electronic polarization, there is an adjacent and opposite charges due to the external field, which means that there is here positive charge, negative charge, positive charge, like that. It is an adjacent opposite charges. So the displacement of adjacent opposite charges are coming together, like plus and minus, positive charge and negative charge together, it is there here also together. So such kind of displacement will also leads to the dipole moment, and because of that the material get polarized. Because of the adjacent and opposite charges, it is called ionic polarization. Okay, so this wholly depends on the location of the charges charges, and as well as the movement of the charges also. Okay, so that's all about the ionic polarization. When we come to the orientation polarization, so the word itself, which gives you the information regarding the polarization, which means that the dipoles are acting here like a arrow marks. Here in the absence of the electric field, all the dipoles are directed towards in a different direction, as well as it is oriented in a different direction. But after applying the external field, so according to the direction of the external field, you look at the arrow mark there, in which direction the electric field is applied, the same direction all the dipoles are oriented. So this is called orientation polarization. So the orientation polarization, which also explained by the formula, that is alpha O, which is equal to mu square divided by 3 kT. Here mu we knew that dipole moment, and K is Boltzmann constant, T is temperature. So the orientation polarization is a temperature dependent quantity, so compared to ionic and electronic polarization. So one more time, it is depends on the orientation of the dipoles. Okay, so next one is space charge polarization. you come to the space charge polarization, it is entirely different from remaining three polarization, which means that it is occurs only in multi-phase dielectric materials. That's what I have given here. And the changes of the resistivity, which means that here on positive and negative charges are accumulated in one phase and this is in another phase. In the absence of the electric field, what is happening, all the charges are separated apart. But when we give the external electric field into such kind of multi-phase dielectric materials, the same way positive and negative charges are separated, but the important thing is at a higher temperature the charges are settled at the interface, which means that here it will accumulate, but opposite charges are moved towards the low resistivity phases, like that. Okay, so and dipole moment is also produced at low resistivity phase. Because of that thing, we used to neglect this space charge polarization for many of the dielectric materials. Okay, so this space charge polarization is also temperature dependent. Okay, so these are the four type of polarization. One is electronic, ionic polarization, orientation polarization, and space charge polarization. So from that, what we can tell that among four polarization, the two polarization are temperature dependent. What are they? One is orientation polarization, another one is phase charge polarization. So with that, this video we will complete it, and in the next video we will look up the expression for the internal field of the in the case of liquids or solids in one dimensional phase. That's what we are going to discuss in the next video.